Hello, my name is Amanda Matson, and I'm here to explain some concepts to my students. In particular, we are doing some programming in the programming language of R, and we're going to do this using the software program called Posit.Cloud. And in Posit.Cloud, we're going to do some things with cumulative distribution functions. So that one is here. And I've got a quick little date stamp. Today's Monday. By the time we're done, we'll be able to use a cumulative distribution function to calculate the proportion of data within 1, 2, and 3 standard deviations from the mean. But to start with, we need to actually make a cumulative distribution function. So I need a code block. The first thing I like to do whenever I'm doing any of this is to figure out what my data are called. I have some data that's about land temperature, and I have removed any outliers from this data. So it's called inner land temps. And the column I care about is the average temperature. So just to get used to it, I'm going to save that for later. Now I'm going to make a cumulative distribution function so that I can do things later. I'm also thinking about things like density when I'm doing this. Sometimes we'll say things like a cumulative density. And so I'm going to call this C-dense. And so I'm creating something called C-dense for cumulative density. And it's going to become whatever I get when I put my inner land temps average temperature into the ECDF function. And when I hit play on this, it will show up on the right as a function. So C-dense is something I can use, and it will tell me the portion of data that are at or to the left of whatever point I care about. I don't know any data points that are in my data set. So just for the fun of it, I'm going to take my data and I'm going to pick a point at random. We're going to look at the temperature 25.861. For all of my examples today. If I hit play another time, I'll get another one. It's random, 21.261, 12.85. It's just a random sample of one. And I just pick an observation, any observation for this. Okay, first checkpoint. Use a cumulative distribution function to calculate the portion of data to the left of a point. So now that I have an observation, I can just type it in. I want my C-dense of 25.861. Or I can write it this way, where I take my 25.861 and I push it into my C-dense function. And I can see that 80% of my data are at or to the left of 25.861. If I pick a data point that's not in there, it will, R will still do it for me, but I'll get a little warning. Or should get a warning. Maybe I got really lucky. Oh, it did it for me without warning. Awesome. Sometimes R gives me warnings about things when I try to pick numbers that it doesn't like. So 25.861, the portion of data they're at or to the left of that is 80%. So that's this one, check. To calculate the cumulative distribution, to calculate the portion of data between 2 points, I need another point. And so let's go ahead, start a new one, like pick 2 points, random. So I'm going to take my inner land temperature and average temperature, and I'm going to do a sample of size 2. So my 2 points at random are 5.44 and 17.58. If you have favorites, use your favorites, but I just wanted to have 2 points. To find out how much data are at or to the left, I'm going to do the 17 density minus the 5 density. And I'm going to do those 2 ways. The first way is how I would do it if I were computing things kind of by hand. And so I'm going to take my CDENS of 17.338, and I'm going to do my CDENS of 5.44, and that'll give me those two numbers. Or I can just say whatever this is. I'm going to CDENS 5.44, and it will just do the subtraction for me. And so the first one was 46%, or adder to the left of 17, and then 19%, or adder to the left of 5. And if I take the 45.6 and the 18.5, I take the difference between the two, I get 27%. And so 27% of the data are between 5.4 degrees Celsius, let's see, yes, and 17.4 degrees Celsius. Oops, if I can spell. I do not like Celsius because it's not capital. There we go. All right, and so I found the two, and then I subtracted. Okay. So this one's done. Check. This one's done. Check. Now I need the portion of data within 1, 2, and 3 standard deviations from the mean. Well, I can find the mean pretty quickly by just having R find it for me. And standard deviation. Let's see, R. The mean is usually called U. And so I'm going to make something called mu. I'm going to take my inner land temperature, and I'm going to send that into the mean function. And then the next thing I'm going to do is make a sigma. I'm taking my inner land temperature, average temperature, sent into the standard deviation function. Now that I have a mu and a sigma, and they show up over here on the side, I come back up here. And instead of doing 17 point whatever, I could do mu plus sigma and mu minus sigma. Because R knows what those things are. I can see them over here. And here, this will be mu plus sigma. And this is mu minus sigma. And so within one standard deviation of the mean, I've got 67%. And so approximately 67% of the data are within one standard deviation. And if I wanted to do 2, I would just do 2 times. Everywhere I've got the ones, I'm just going to write 2, 2, 2. And I hit play. 97%. Copy. Paste. 97% of the data are within 2 standard deviations of the mean. And my 2's become 3's. And 99.7. 99.7 of the data are within 3 standard deviations of the mean. Just using that cumulative density function. And that's how I use that CDF to calculate the proportion of data that are between 2 things. As a bonus, let's plot it. I'm just going to take my inner land temps and use ggplot with the aesthetic where x equals average temperature and plus that BCDF for empirical cumulative density function. And I hit play, and there it is. And so I can see my values living everywhere and then it stacks it on this graph. Right, that's everything. So I hope you figured out how to do some things. Feel free to rewatch until it makes sense or send me a question.